Thank you so much, Farheen. Well, Amazon.com, whenever we hear this name, we understand that the packages will be delivered on time. Okay, there are some exceptions, but we'll talk about those exceptions and how promise delivery date is a key factor for Amazon.com to deliver packages to customers. But there is a huge manual and mix of manual and automatic workflows behind these operations. So what usually happens, we will go through these 4 areas today. We'll see that how AI, not only just as a UI, but how generative AI, agentic collaboration could solve many of these manual processes. And now we have better explainability, solve a lot of money in delivering packages and understand where the customer problem lies. So when we order a package from Amazon app or Amazon website, first thing that we get is the delivery date, approximated delivery date. That is called promise delivery date. Amazon is so determined to give you that package within that delivery time that it is ready to make any cost compromise, cost optimization from their end to deliver the package to the customers. And that is why customer obsession is a very, very big, like a major DNA within Amazon. But what usually happens that so many orders are coming through Amazon website and Amazon app. A lot of planning needs to be done. Which location, which amount of drivers will be driving these packages from sort centers, how airplanes will be flying from one city to another place and give these packages to the shortest amount of time. Humongous amount of optimization is running at the back. And these optimizations, we calculated that planners who are really planning this optimization, some of these are automated, some of these are system generated, but some of these are pretty dynamic based on the time of the year, dynamic socioeconomic nature that only a human planner understands. These planners have tribal knowledge. They're working in Amazon for quite a lot of years. They understand under which circumstances of the year they change the plan to accommodate to the optimization of these packages delivery. So we calculated, we saw 10 million data points across the year are needed to be dealt with. Unbelievable. A human planner, a group of human planners, it's very difficult to understand which data point is actually related to another one. What is the causal inference? Who is associated to what and who is causing difference to the other parameter? Then manually identifying them and correcting it. And finally, if it doesn't work out, there will be a lot of losses in customer churn, not missing the promised delivery date. And we calculated it could go up to $150 million. So let's hear from one of our customer voices. She couldn't be here today, but she wanted to explain what these parameters are, how planners are working, what does that network look like. So she's here today to explain the problem. And wait, I'm just trying to find the pointer. Pointer is over here. Yep.
Hi, my name is Ritika. First of all, let me express my deepest regret for not making it to this presentation in person. This is a project that was really close to my heart, and I do hope Subhro gets valuable feedback from this audience. With that, a quick introduction. I've been with Amazon for over 9 years now in multiple roles, spanning product, program, and business. In my last role, I was Principal Product Manager Tech for unconstrained volume and constrained volume planning products for Amazon Logistics. In my current role, I've become a customer, and I'm Senior Manager Planning for Amazon Logistics. So what do these products do? These products essentially help determine the unconstrained volume ask from last mile in AMZL for a rolling period of 17 weeks, and then help locate available capacities across under the roof, out on road, and mechanical to identify bottlenecks, solve for bottlenecks where possible, and then publish the plan that last mile is preparing to solve for in a given week. So the products solve the problem of managing a behemoth computation week on week, help maintain the plan of record effectively, and have a higher uptime versus offline Excel-based templates that were being used to plan earlier. Solves for reliability, traceability, and speed of computation. But as we all know, no planning system is perfect. So as a planner, I need to be sure that whatever a computation is spitting out today actually makes sense. And the planner usually gets this confidence by looking at some of these data points. How does a plan for week X that's been computed this week compare to what was computed last week? If there's a change, what is that on account of? How does the plan for ramp up to an event week compare to the ramp that was planned last year, same event? Which stations and weeks have bottlenecks and what are the bottlenecks on account of? And so many more questions that a planner is trying to make sense of from a view like this. Now let's do some math. Take EU for example. Each constraint plan has 119 days. Let's say each day has one next day, 4 same day cycles, that's 5 cycles. Not every country has it, but for the sake of this math, let's assume that. Every cycle has more than 100 metrics. So EU, with its 249 stations across 10 countries, has a whopping 15 million numbers to look at and make sense of. It's completely mind-boggling for a planner to do that. So the idea was to develop a plan evaluation engine that can help planners almost have a conversation with the plan instead of having to download everything in an Excel sheet offline, build a script on top of that, and then do a detailed dive deep on it. The goal is to reduce dependency on skills that a planner acquires only after months of experience, improve the speed of planning, and to reduce errors in the planning process. So that's the background of why we built this plan evaluation engine. And with that, I'll hand over to Subhro to take it forward. Thank you, everyone.
So now that we know the problem, how AI is solving it, and especially how generative AI is playing a role in it, we started analyzing this problem by not looking into LLMs. We did not think that LLM will solve the problem. We wanted an automated solution, a human-like mind to go through all these parameters, try to understand what is optimization. And evidently, after a lot of research, we came down that, okay, can LLM solve this problem? And planners can interact with these problems, with these LLMs. So initially models, we started just with LLMs, but it could not solve the problem. And then we decided, okay, how about Agentic AI? How about having two agents talking to each other, analyzing these numbers, optimizing the paths, how the trucks will be delivered in different locations in the most efficient way. The final target was, in sort center, we should not have way too number of people and less of packages, because that's a lot of excessive human power that we have, or a lot of packages on the floor, but not having drivers or people to help us to get these packages packed. In order to solve that key problem, the optimization that is required across many delivery stations across the globe, we decided this one framework can help us. What are we doing here is that we take the plan that is generated by Amazon, without having the constraint of socioeconomic nature, any kind of global political situation that is going on. Without considering all that, a plan is generated. And we have the formula written with the tribal knowledge of planners. We give this to the data processing, and then the magic happens. With Agent 1, we create a graph of multiple parameters of these plans. And when we create this graph, we apply weights to that. Which parameter is more important to us? Again, with our tribal knowledge. When we understand these weights, we give it to the model and then ask the model, hey, can you please look into these parameters? Who is causing change to whom? And the plan will reflect differently in future under all the circumstances of socio-political nature, global situations. We create these graphs, put different weights, and then add formula to that. When we pass all these information to the LLMs, the agents coordinate the optimized plan that come out of it. So I'll definitely not go through the whole thing explaining line by line here, but I want to give a very crucial information. Probably you can also take something out of this when you go back to your laptop and then try to understand, is that the left-hand side algorithm, this is the crux of Agent 1, what we have just seen before. So Agent 1 creates a graph, right? How the graph is created, where is it coming from? So we went through a paper released by some Chinese researchers who explained the fact that you create a heat map of all the parameters, who is dependent, what kind of probability that one parameter is related to another parameter. That's just a heat map that we can generate. Out of this heat map, try to find out this entire heat map dependency as a graph, and then you apply weights. So the left-hand algorithm is called LACER, L-A-C-E-R. LACER algorithm helps us to find the graph, and then our formula, the tribal knowledge that we have, we use this formula on this graph to make weights based on different situations of the year. And when we apply that, we have the right-hand side graphical model. Now we know which parameter can cause causal inference versus just association. That means one parameter is not really causing another parameter change, but is just associated to them. We have to make this difference. And in behavioral economics, that is a never solving problem. It's just probability. So we are also relying on that probability, that how accurate we can get causal inference and not just association. Using this algorithm, we basically created one interface like this, which is now integrated to the planning machines, what Richika has just shown in her video. Now planners can look into these plans and chat with this kind of interface. Hey, why my plan is different? Like just a small video of this that we recorded. It is just explaining to a new planner who comes into the team to understand how UVP, CVP, like unconstrained volume planning, constrained volume planning, they are related to each other. What is the dependency? How the graphs are generated? All these key things, the causal inference that this solution can provide. Again, this is just a sample UI we wanted to present to explain how does it work, and this is integrated into the planning software that Richika has just shown. We are in process of integrating it to multiple planning softwares, but this is how it looks. Now that you understand how the solution is like as an end product, this is the architecture that required us to take it to production. It is still in a lot of production mode for a couple of teams, and a few teams has implemented this in production. So overall, this architecture basically looks like this. And how do we take it forward? The key thing to speak about it here is that we are using Bedrock Cloud model. Definitely 3.7 is giving us nice reasoning to it, but we are using custom AI agents, which is provided by LangChain. Now, as you can see, LangChain has given us the way of delivering solutions in a very custom open source manner. When we wanted to keep the control in our hands, we took this solution and then calling Bedrock Cloud 3.7. Tomorrow we will be going for other models which would be coming in future, and we will be exchanging the models. But as you can notice, there is a problem in this solution. The problem is that the agentic method, the algorithm that you have put inside, All these are pretty custom. You need to have a good engineering team to manage this LangChain-based agents. How about we don't have upskilled engineering team in our organizations? What do? We ask customers not to worry about that. We do have managed agents in Bedrock. And in order to talk about it, I'll invite Antonio, who will describe how customers can leverage managed agents and solve similar problems like this. Antonio?
Thank you. Hi, everyone. I'm Antonio Rodriguez. I work in the Amazon Bedrock team, and I'm a specialist solutions architect within the team. And yeah, if we look at the common ask from our customers, and many of you probably, if you are building agentic applications, has faced this, we can summarize these three. The first one is that we are hearing you asking us, help me automating complex workflows like the one that we saw before. And right now, we have many options for doing that in the industry, I would say. We saw LangChain. We also, you probably are familiar with LangGraph, Crew AI, et cetera. So we have many agentic frameworks in general for helping on that. We also have the classical tool use or function calling that the models provide natively and that we also support natively in Amazon Bedrock for all the models that has this capability. But at the end, the goal is always, how do I automate this? So I want to make my life easier. I don't want to deal with all the complexity of having to host the open source framework. I don't want to deal with the fact that I have to be up to date in all the libraries and releases that are appearing, all the possible issues that might appear in the open community and so on and so forth, right? So I want Bedrock to help me managing all of that heavy lifting, and I want to really focus on what is the value that I have for my business. Second thing is, help me move faster, right? So I need to accelerate on this. We are at the GenAI speed. We were discussing with many of you during yesterday roundtables and today that the life cycle is of a model from the same provider even is less than 6 months, right? So in less than 6 months, you already have a new model that is already making the other one be legacy for all reasons. That includes quality of responses, latency, and cost, right? So there is a need for automating and moving fast because otherwise your competitors are going to win a big chunk of the market for you, or you are in risk of being deprecated, right? So you are in risk of not being up to date anymore in the business. And finally, there is an ask for help me finding more robust and scalable solutions, right? So that's probably one of the downsides of going with the open communities, which, by the way, we continue supporting and will continue supporting also from AWS. I mean, all of those frameworks like LangChain, LangGraph, Llama Index, and so on and so forth. We will continue. Actually, we are building whole teams that are going to be even more focused on those frameworks moving forward. But at the end, it's always a theme about, I need this solution to be robust enough. I need this solution to scale automatically. If I have thousands of customers and then I suddenly go to millions because my business is becoming very successful, how do I make sure that I have the power, the infra behind for supporting that growth? So for those reasons, mainly, we came up with Amazon Bedrock Agents, right? So Amazon Bedrock Agents is a way to offer you a fully managed experience for building agentic workflows in AWS and inside the Amazon Bedrock ecosystem. And we have a choice of foundation models. Actually, right now we have all of the foundation models that you have available in the platform, including the reasoning models as well. So we have made changes in the last 2 weeks or so to extend the timeouts in examples so we can actually support reasoning models that are taking more time to do all the task planning and the choice of the tools and so on and so forth. That includes Sonnet 3.7, that includes DeepSeek R1 as a serverless model now as well, and all the Amazon Nova models and so on and so forth. We also have features for things like memory, long-term memory. We support integration with the rest of the Bedrock tooling, like knowledge bases, guardrails, and so on. We give you flexibility now to customize the prompts that you want to use, to customize the orchestration that you want to use if you want to define your own orchestration because you are not happy with the React approach that Amazon Bedrock Agents is doing for you automatically, and so on and so forth. And we also offer you all the traceability, observability that we can bring inside Amazon Bedrock. And that also includes, obviously, all the security and privacy that we have in the ecosystem, so that you make sure that your data is always private to you. And finally, we recently added multi-agent collaboration, which is now in general availability since last week, which allows for use cases like the one that we saw in the session before, if you were here from Detsu, where they actually show the multi-agent collaboration use case. But there are many customers who are currently using these kind of applications. I showed you a few examples from financial services customers. In example, we just pick an industry that seems to be adopting agents very fast, at a very fast pace. So all of those customers are having multi-agentic applications in production right now. So many of you have been asking me in this conference how real it is, how ready, how mature are we for agents to use a multi-agent collaboration in the real applications in production. All of them have it, and all of them are seeing the benefits of it already. It is always a design choice. Should I go for a single agent that does all the work? Should I go and split my task into multiple agents? It's always a matter of accuracy of the tool choice that the agent has to do, and so on and so forth. But this is, by the way, the way that you will configure the models that are available, and so on and so forth. This is just the Bedrock Agents optimized models that you have already, which are models that are designed to speed up the agent even more than what you classically have. If you disable the Bedrock Agent optimized selector, you actually have the full set of models that you have in Bedrock right now. You can do it with this drag and drop interface, but you could also do it programmatically if you don't like UIs. We also have a chat that allows you to create the agent with a conversation, which is more user-friendly for many developers who has to have access to the creation of agents and they don't know how to code, or they don't know the details on how to configure an agent, and so on and so forth. And as I said, you have many settings for tweaking, personalize, customize the agent configuration that you want. Now let's see a demo of another feature that is very popular, which is called inline agents, right? So inline agents is the ability to actually define what you need from the agent at runtime. So actually you have like a skeleton that is generic for your business, and then during the invocation that you do to the agent, you actually specify what are the tools that you want to be exposed to that agent and the configuration that you want. That is very handy when you actually have many agents in production and you don't want to pre-create all of them, right? So you actually need this dynamism where you actually can pass parameters where you say, I want this tool, I want this knowledge base to be exposed, or I want this configuration for this specific invocation that I'm doing now from this user. And I'm going to show you a quick demo on this. You might be asking why I'm going to a conference where AWS is showing me the latest innovations, and all of the demos are based on Streamlit. It's just functional, and sorry for that. But here you will see a Streamlit-based demo of this use case where we actually have an HR agent. In this case, it's a human resources agent that we have configured here. So you will have an interface that looks like this. And in example, I can decide that I'm a professional assistant in this case. I'm assuming the role of a professional assistant in human resources. And then I ask a question about my employment. I can ask, hi, how can I help you today? And then I can decide what are the tools that should be available for this user, right? So actually, I have an ID of the employee. And based on that, dynamically, I can say that this employee 1001 that we see over there should actually have access to the knowledge base with the company policies and nothing else, in example. And then he could be asking the question, what is the annual bonus requirements, right? So actually, you can check that the answer that was given to this employee is not giving numbers, because this employee doesn't have the access level for actually accessing the information that has the numbers, the monetary values, and so on. If he has another role in the company, then this is shown, because there is another index that is shown to this customer, to this user from the knowledge base that we have. And that was passed inline in the invocation that we did to the agent. We could also see another use case where we actually enable the budget approval and the vacation approval tool for this user. Maybe I'm connected as another employee that actually should have access to that, because maybe it's in a unit that actually should be using these tools that I have internally in my agent and in my intranet, in example. And in this case, I could be asking another question. I think I do it later over here. where actually we say, I will be out of the office tomorrow, and then it already checks with the tools and says, OK, you have 24 days of vacation remaining right now. That is because that user, as I said, is already listed in the agent that I defined in flight during the invocation. But it's, again, the same API for all of them. I'm just changing the parameters, right? So this makes it very handy, very useful. I don't have to pre-create multiple agents for everybody. Now, we can see other example. This is actually for a unified customer experience, which is probably the most common use case that we're seeing our customers doing these days. So in example, I could be asking to a mortgage assistant, right? So I have a given mortgage, and then I need to ask a question. When is my next payment due, and for how much? So you actually can see that in this case, there is an agent that is calling a collaborator, right? So an existing mortgage assistant tool that is being called. This can be another agent, actually, that the supervisor agent is deciding to call. And as I said, this is typically done because you want to increase the accuracy that you are doing in the tool selection. Here, this one could be giving an answer that says actually the information that I need. I could be asking a more complex question. In example, what's left after that? And then what we see is that it goes and calls an API that says get mortgage status. And then based on that, it's going to get how many payments are due for me. And I can continue doing questions that are even more and more complex. Like an example, I could be asking, what's my current rate, and what are the rates for the new 15 years fixed mortgages? Is there a big enough difference to make it work for the pros and cons and so on and so forth? And then as I'm asking a very complex question, the supervisor agent that I have here says, OK, hold on, let me make a plan on how I'm going to answer this. And then it actually starts asking other sub-agents that are configured as secondary to this one. And then it starts doing some steps for getting the information. In the first step, it's calling the existing mortgage assistant agent that is giving information on what is actually what I have right now. It calls an application agent that actually gets the rate history that I have had. And then it finally builds a comprehensive answer by combining all of the information that it got from the sub-agents that we saw before. So this is what we call multi-agent collaboration, which is something that, by the way, you can configure very easily with one click in the console or with one parameter in the API. What happens if we also want to run code? And the typical case is that LLMs are really bad when you have to do mathematical calculations, right? So one thing that we could be doing here is, an example, I'm going to ask a question here that is, well, here is actually checking, did I get my verification document and so on and so forth? So it will answer, again, from another sub-agent and so on. But I could be asking a question that actually require to make some mathematics. And actually what it's going to do is that it runs a piece of Python code, as you can see, using a feature that is called Code Interpreter in Amazon Bedrock Agents to actually calculate the mathematical financial information that I'm actually asking about, because it requires that it actually applies a percentage, an interest rate, and so on and so forth. And by doing that, we actually don't even need to define a tool for exposing mathematics to the agent. It is actually doing it automatically just because we enable the code interpreter in the agent. By the way, it can also output in the chat graphs. So it can write a snippet of matplotlib, in example, Python code, and then it can show to the user, this is what is left, and here is a graph of how you see it, right? So it's very easy to give these kind of experiences with Amazon Bedrock Agents today. All right, so again, 2025 is the year of the focus on agentic applications. We really see it. Actually, we think it's the year of agentic applications in production already. I think that last year was the year of the prototypes and POCs with agents. And what you are going to see from Amazon Bedrock moving forward is more and more capabilities for doing that in a way that is scalable, that is production ready for you, where you have full visibility into the evaluation of how good is an agent doing something, more and more monitoring and observability so that you can automate the whole process and you can trust in the applications that you're building with Amazon Bedrock Agents, and the same with the other frameworks that we are supporting from Bedrock, as I said before, from the open community and even from the raw function calling that you have natively with the products today. If you want to dive more, we have this repository. In this QR code, you actually get a link to a GitHub repository where we have a lot of samples for building with Amazon Bedrock agents. Actually, you have blueprints that you can directly import into the console for your own accounts. And then you could spin up agents that do all sorts of use cases that we commonly see in our customers. So I recommend you checking that out. We would love to see what you are building next based on this. And also, I wanted to share a couple of blog posts that we have recently published. These blog posts go through the best practices that we recommend for building agents today. That includes everything from when to decide to use agents, how to configure those, what are the best design patterns, how to optimize for things like latency or cost, and so on and so forth. So again, very much a recommended reading if you like agentic applications and you are bored at home and want to make some break. So that's the content we wanted to share. We want to also thank our folks in Amazon Logistics for telling the use case that they have and how they are using agents with us today. And thanks all of you. Please remember to fill the survey, and thank you for your attention.